All right, so like I mentioned, section 1.4 on the worksheet, you are not going to be doing number 7, number 10, 11, and 12, okay? Now, there are some things that you guys have to know how to do. Here you go, Rigo. Which is knowing what a distribution curve is, okay? So a distribution curve looks like this. So I don't know if you guys remember that we did this a little while ago, but we drew this thing where we had like 5 lines total. Okay, so I'm going to draw those 5 lines. Okay, remember we were doing this with standard deviation, so how many deviations was a certain number from the mean and stuff like that. What we are going to do is we're still going to label this the way we had it, right? This is still the mean. This is the mean plus a standard deviation. This one was a mean plus 2 standard deviations. This one was a mean minus a standard deviation. And this last line was a mean minus 2 standard deviations. Now, so far we've done that already. A distribution curve means that you're going to basically draw something that looks like this. Now, I don't know if you guys have ever heard of the term bell curve, okay? But that's kind of the idea, okay? Now, in a distribution curve, you guys have to know the following data, okay? Right here, when we look at this piece of information here and this piece of information there, those two blocks hold, I guess you could say 68% of the information, okay, in those two blocks. So within one standard deviation, you have 68% of the data, okay? Now, if you go 2 standard deviations away, then it's I think it's a 12.5%. I gotta double check that really quick. Okay, but 12.5%, is that what I put? No, it's 13.5, sorry. I thought it was 12.5. It's 13.5. Okay, so, and then if you go further out, you're going to get a 2% here. So this is what we've drawn up to now, okay? To do normal distribution, we need to finish up the rest of the 100%. Right now, we're at 99% of the data. If you calculate all those percentages, we're at 99%. So there's 1% missing. So to do that extra 1%, we extend this out, okay, and we're still going to draw. Now this is going to be 3 standard deviations away, okay? So to do this one, you're going to do the mean plus 3 standard deviations. The other one is the mean minus 3 standard deviations. So this is going to be 0.5% and 0.5%. So this is a graph that you guys have to remember. The numbers inside, you guys have to remember those. Okay, because sometimes they'll say like how much information is held within 2 standard deviations. So you're going to say, oh, that's 13.5, 34, 34, and 13.5. You add it together, that's going to give you your answer of how much is held inside. If they just want how much is held inside the first standard deviation, well, it's 34 and 34, so that's 68. Okay, how much is held within the first 3 standard deviations? 100%. Okay, the first 3 standard deviations hold all of it. Okay, so there is no 4th standard deviation level for this stuff. Okay, so that's one thing we have to know, because we're going to have to do that in the back. Okay, and it's relatively easy to do, so don't freak out over all this stuff. It's just I need you guys to know what it looks like, so when we draw one, you know how to label it, okay? Granted, the numbers on top, right here, like you have your mean and then you have all your other stuff, those we're going to have to calculate, which are pretty easy because they're going to give us the information anyway, okay? So there's that. Now, the standard deviation, or sorry, the normal distribution curve can look multiple ways, okay? It might look like this, Or maybe it looks like this. Or else it can look like this. Okay? Now, if you think a bit, think of this kind of like a grade scale from A through F, right? If you were to look at the first graph to show like the number of A's to number of F's, okay, let me move this up here. So from the number of A's to number of F's, the first little graph over there, are there more A's or F's? A's. So that would be a positive thing, right? That there's more towards the good grade range, right? So we would say that this is positively skewed. Now, if you look at the second graph, it looks like there's more F's than A's, right? So that would not be a good thing. So we would say that that's negatively skewed. Now, in the last graph, it kind of looks like most of the grades are in between A to F, right? They're about the C range. So that's called a normal distribution, okay? So normal distribution or normally distributed. Okay, so positively skewed means that there's more numbers on the side that you would like. Negatively skewed means that there's more numbers on the side you wouldn't like. Okay, and then normally distributed means that it looks like a bell. Okay, these are called bell curves because they look like bells, right? Kind of like they have the shape of a bell. So if they look like a normal bell, then you say it's normally distributed. Okay, but if they're skewed a little, like more to one side or more to the other, then we say they're positively or negatively skewed. All right, so you should be able to answer questions 1, 2, and 3 right now on your own. Okay, you don't need me to help you do those. It's just look at the way the graph looks and you should be good. Okay, now if we look at questions 4, 5, and 6 on your homework, it says the bar graph below displays the heights of the students at a high school. Use the graph to answer the following questions. All right, question number 4. So like I said, we're going to work on your homework together. That's what I'd like to do. It says approximately what % of students are between 61 and 67 inches tall? So just so that we know, I'm going to make this really quick. 64 to 66, 67 to 69. How many students are 61 to 63? And they say approximately, so give me an approximation. What do you think? 11? All right, we'll stick with 11. How many students between 64 and 66? Someone said 19. So, all right. 67 to 69? 35. About 35. Okay, so we got 35. Now, if we add all that stuff together, we get 55. Okay? Now, it's saying what % of students. Okay, so I'm just getting out my calculator here. So in order to do a percentage, I need to know how many students divided by the total number of students, right? So, all right, let's figure out what we have in total. So 58 to 60, how many students do you see there? I say maybe like 3 students. We already did 61 to 63, 64 to 66, 67 to 69. We know that's 55 total. From 70 to 72, that comes out to about 19. From 73 to 75, that's about 11. And from 76 to 79, that looks like about 3 as well. So let's add up that part right here and then add it to 55, because that's the 55 we already figured out. So 3 plus 19 plus 11 plus 3, that's 36. So 36 plus 55 is 91. So we're going to say total is 91 students. Now, we might be off a little bit, but that's okay. They want us to approximate, right? So if there's a total of 91 students and 55 of them are within that range, then to figure out the percentage, I'm just going to divide. 55 divided by 91. And I get this answer, 0.60439, etc. What's the approximate percentage for that? You're going to round it to the nearest tenth after you figure out the percentage. What's our percentage for that? Someone said it. Go ahead. Approximately what? 60 point what? I just want one number after. 60.4. And there you go. That's not that hard to do, right? You're just counting some numbers, dividing by a total. We already know the total is 91. That's what we're going to assume. Okay? So let's look at number 5. Approximately what percent of students are between 64 and 75? So we're looking at 64 to 66, 67 to 69, 69, 70 to 72, and 73 to 75. So let's see. From 64 to 66, there's 19. This is number 5. Sorry, I forgot to put that. There's 19 from 64 to 66. From 67 to 69, we said there were 35. From 70 to 72, I said there was 19. And 73 to 75, there was 11. That's the total number of students that they want me to figure out. Okay? So 19 plus 35 plus 19 plus 11 is 84. Well, I got to divide that number by the total, right? So that would be 84 divided by what? 91, right? So that comes out to 0.92307, which is approximately what percent? All right, 92.3. Thank you. So there you go. All right, you guys do number 6. Okay, you'll do that on your own. Go to the back. So notice number 6 is going to be easy. Okay, you're just going to add some stuff up. It's not that hard. 8 and 9. Okay, let's look at numbers 8 and 9. So I'm going to do number 8 for you guys. You guys can do number 9. Okay, so number 8. Yes, it's a word problem, but all we're going to do is sketch a normal curve. Now remember, in order to sketch a normal curve, I need to know, let me go back up here really quick. I need to know my mean and my standard deviations, right? I just got to add or subtract those standard deviations over and over again. So I need to know my mean and my standard deviation. That's it. And then I can draw this thing. So for number 8, before I even read the problem, since they said sketch it, I'm going to go ahead and do that. I'm going to just draw something like this. Here's my middle. I'll go over here. That's 1, 2, 3. And I'll go 3 over this way, or 4, sorry. But I'll go 3 actual lines this way. Okay, so there's my setup. Before we only used to draw 5 lines, now we're drawing 7, okay? Because we need 3 standard deviations, not just 2. Now, let's read the problem. It says the average weight of a tomato in a tomato garden is 10 ounces. Well, average weight, that's your mean, right? That's your average. So they say 10 ounces. So I'm going to put right here 10 ounces. Okay? Then they say the standard deviation is 1.6. All right, well, to get the next line to the right, I'm just going to add a standard deviation. So 10 plus 1.6 is 11.6 ounces. Now, to get the next 2 lines, I'm just going to add 1.6 again. So this would be 13.2 ounces and 14.8 ounces. Now, to go backwards, we're just going to subtract, right? So we'll subtract 10 minus 1.6, that's 8.4 ounces. Okay, subtract it again. So that's 6.8 ounces. And then if you subtract it again, you get 5.2 ounces. I mean, that's really the hard part to this. I guess the next part that could be kind of tough is you're going to have to draw your, you're going to have to draw your standard curve here, okay? So your normal distribution. And I want you guys to do this just as practice. Label the percentages, okay? 34%, 34%. Okay, so that's the first two in the middle. Then 13.5%, 13.5%. And then 2%, 2%, and then 0.5%, and 0.5%. Get used to writing this out, because what's going to happen on like the state test, and we're actually going to practice this later on, they'll ask you like, okay, some of the tomatoes were 12 ounces. What percent of the whole does it represent? Well, 12 ounces would be between 11.6 and 13.2, so that would represent about 13.5% of the information, the 12 ounces. That's where it fits, okay? They might say, you know, what percentage of the tomatoes is from 11.6 ounces to about 14.8 ounces, or past 14.8, so 3 standard deviations. So you're going to start 13.5, 2, and 0.5. That's 16%. Okay? So they'll ask you little things like this, so you have to know the numbers that represent those percentages so you can add them up properly. Okay? So you're just going to have to make sure you memorize those. All right? So 34, 34, 13, 13, well, 13 and a half, 13 and a half, 2 and 2, and then half and half. Okay, so number 9, you're going to do it the same exact way. They're going to tell you the average score, that's the mean, is 76. The standard deviation is 6.2. Okay, and they want you to do all 3 standard deviations. So that's what we did. We wrote everything out. So very easy assignment, not that hard to do. You guys do number 9 on your own. If you're going to look at the front, remember you're only doing 6. That's all you got to do. And number 9. Okay, 6 and then number 9 as well. So I'll go ahead and stop there. If you guys have questions, let me know.